All right, we should be live recording. Let me check. Yeah, okay. All right. So we are going to branch now into the next subsection or sub-subsection, depending on how you look at it, of our module. We are going to go back to using Lambda expression to do traditional tasks that they are well suited for. Okay? So this is relatively, I would say, easy peasy type of material there. We are going to go back, we're going to start with selections, okay, filtering. So we are going to go back to our list of friends here. So we have a final list of string friends, and we use arrays.asList here to populate it, to initialize it with a bunch of names. So we have 6 first names here. What we want to do is we want to define this pickName method here, pass the list friend, and say, like we did in the previous example, we want to extract, all the names that start with a letter, for example, N or Z. Okay, so we are going to kind of iterate over the simple example over and over to introduce progressively new technique. We keep a simple example because if we start injecting stuff like, for example, any application domain, like you saw in the practice project, as soon as you talk about an application domain to make things more realistic, then you have to lecture about that application domain, and that detracts from staying focused on Java. So in those lectures, we're going to always play with those toy examples, okay? And then the practice project is supposed to be there to help you scale up what you learn and apply it, okay, in a context that is a little bit more rich, more realistic, I would say. All right. So let's take a look at how we can write the trivial, quote-unquote, trivial pickName method. So public static void, so it's going to be a static method. We are going to take the list of name. We are going to take the starting letter, which, just to make it easy, is represented as a string. We could have used a character, I guess, but string is a reference type, so that makes it kind of uniform with everything else. And here's how we can write this when we are a traditional, I would say, Java developer. Okay, so we always go traditional approach, then Lambda, then we try to refine into good use of Lambda, okay, or smart use of Lambda. So in this case, we have what is referred to nowadays as an external iterator, aka a loop, okay. So we didn't go the lowest level we could go. We kind of like tried to save ourselves the trouble. We went with an enhanced for loop. So it's relatively clean, right? But there are a few things that are still annoying, that are still source of bugs and stuff like that, okay? So the things that are source of bugs, potential bugs, are the things that are highlighted in yellow on this slide. So initialization, we carry around that null value. It's a special case. So one of the things we are going to do in the next 2 slides is not only we are going to reshape our loop like we've done, okay, previously using Lambda, okay, and internal iterators, but we are going to also get rid of that idea that, we have special cases. We have a special value here, and then we need to test for null. And guess what? If you do not test for null properly, the only little itsy-bitsy problem that you have is null pointer exception. So that's why null is such an annoying thing. If I initialize to 0 here, before a loop, and then I do a loop, then I test, okay, if the result is 0, blah, blah, blah. Sure, it's overhead, okay? But there are less chance of things going wrong when you are testing for values like that, sentinels, than when you are testing for null. Because if you miss testing for a null correctly, and you try to dereference that reference, then this is when you get your runtime exception. So the whole philosophy here is always with Java and any strongly typed compiled language is we want to avoid finding out problems at runtime. Okay? So it's just a philosophy. I'm not saying it's the best. It's a good one, certainly. There are equally good ones over good ones. But this is what guides all of this work here. So we want to get rid of this. Okay, we don't want to have to handle null like that by hand. And we would like to get rid of that break statement too. Because a break statement is really a go-to statement in disguise, right? It's, it's a disciplined go-to statement. So I'm probably like talking about things you don't care because you're like too young, but none of you has ever used a go-to statement, right? You? You're getting old. No, I'm kidding. Okay, but there is this thing like if you go back in programming languages, right? The first form of control we had was a goto statement, which was just a way to say branch execution to that line over there. And if we go even backward, more backward in programming language, we had numbers for each line of our code, and we would say things like if found different than null, go to 25. 25 being the line number where you had to branch execution. Stop laughing. This is stuff we had to deal with. No, I'm kidding. But you can imagine how messy that gets, right? Go to and go sub, which was the equivalent of a function call. But yeah.
I have a comment about go to. Like I know two cases. Like first case that is used in modern world is all kind of bat files in Windows. They use go to in some cases, and other case is in C and C++, because you can have many calls for different functions, and each of them could fail at some point.
Yeah.
So, and it is very heavy to perform cleanup at each stage. It is useful to use goto at some point and perform one cleanup after each stage. For example, if you cannot allocate the memory or something like that.
Mm-hmm.
So still goto, I think in some cases can be useful in some languages.
Okay, so the remark just for the recording, okay, and it's a good remark. The first one, actually, I was not aware that .bat scripts still use goto.
CMD files.
Yeah?
Yes.
Okay, so Windows scripting apparently, or at least the basic command scripting on Windows, not the PowerShell, is apparently using still goto statement. I didn't know that, so that's good. I mean, good. I'm joking, but the second thing is actually really interesting, because you mentioned that there are some cases where goto statement, and nowadays we use goto statement with labels, okay? So we don't use line number anymore. But goto statement with labels are still used in production code nowadays in C, C++, and that's true actually, and that's actually interesting, because one of the places where they use that kind of construct to recover from error, so your use case was actually right. This is the only use case that I know of that is also favorable to using goto statement. And you can find examples of that in the Linux kernel source code, which is interesting, because this is probably one of the most interesting piece of source code that you could ever possibly study. Okay, and it's written by people that are really profoundly good at programming, and still you see something like a goto statement, and you might wonder, why are they doing that? Well, the answer is that yes, there is a specific use case where you can have, let's say, different types of errors popping up in one of your methods, okay? And the problem is that you are starting doing some things, like you open a file, you create a file, you open a socket, you send some data, blah, blah, blah. You do a multi-step process. And that process can fail at any of the step. And the problem is that if it fails after the first step was successful, you need to undo the first step. If it fails after the second step was successful, now you need to undo the second step and the first step, maybe. Okay, there are side effects you need to counter. So if you are in a situation like that, yes, using goto statement allows you to recover. It's not that you could not do it without goto statement, but it's a lot cleaner. The code, paradoxically, the code with goto statement in that specific scenario is a lot cleaner to deal with. Okay. So I guess, yes, there is something to be said about goto statement. One thing, at least, that we know of. Question?
For loop is ending after the if loop.
What about the for loop?
The for loop is ending after the if loop.
Okay, if is not a loop, so when you say the...
If condition, sorry.
Oh yeah, okay. So the for loop is ending, yes, it's ending before system.out.print, okay? When you do not have curly braces after, that means one statement. So inside that for loop, I have one statement, which just happens to be a multi-line statement because it's a if statement, okay? All right. So yeah, the for loop encapsulates the if statement, and then whatever comes after, like system.out.print, that's outside the for loop. So here's how we can try to make things a little better. So we are going to switch from an external iterator to an internal iterator, but we have done that already before, okay? So nothing new here, is just repetition to get you used to that, okay? So in this case, we generate a stream. So we generate our stream from the names parameter. Then we apply a filter. So we pass the lambda. This is a lambda that's going to decide which element in the stream we're going to keep. And then we use that, so filter is one of those intermediary stream operation. It takes a stream, produces a new stream with a result, okay? And then find first is one of those terminal stream operation. It takes a stream, okay, and is going to produce a result. So some of the terminal operation just do side effects, like for each, you know. Some of them are going to make the sum, do compute the descriptive statistics, whatnot. I mean, they're going to produce one result. So find first, the idea of find first is that as soon as you have an element coming into the input stream of find first, that's it. Find first is done. Find first found at least an element, the first one that became available. That's it, it returns. And this is interesting because this is the first code example. I know some of you have been asking about what do you mean by lazy evaluation, okay? This is one of the first code examples that actually opens the door to introducing lazy evaluation. The idea of lazy evaluation, this time I can give you a more concrete example. We are still not yet in the nifty little details, okay? We'll have some slides for that. But here I can give you a concrete example of what lazy evaluation does. In this case, let's say that I have 50,000 names in my names parameter, okay? In that list of string, I have 50,000 strings. 50,000 strings and 50,000 of them would pass this test. Okay? So the question is, how many times do I apply this lambda? As a natural response when you are like a Java developer, right? It's to say, well, if you have a list of 50,000 strings and you want to filter them first, then you are going to look at the 50,000 strings, apply the filter, and decide you're in 50,000 times, and then I pass that stream to find first, and find first goes, I take the first one. Okay? It's wasteful, right? It's wasteful because you did a lot of computation, okay, in your pipeline, here in your stream pipeline, you did a lot of computation just to come to the conclusion, I'm going to take the first one, okay? So imagine somebody does that to you, ask you, you know, to prepare like, I don't know, 50 different essays on different topics, and then they go like, well, I just needed one, thank you. Okay, so that's frustrating, right? So this is exactly what we're dealing with here. So that means like, lazy evaluation means exactly what you would think. Lazy evaluation is if I know you are going to only read, for example, the first part of my annual report, you can be sure that I'm going to take a lot of care of that first part, and then the rest I'm just going to dump information or even, you know, leave it empty to see if you can catch it, right? It's always a thing interesting to do with management. But so in this case, that means that at the end of your pipeline there are terminal operations, and these consume the streams. But instead of execution going like this, starting with names, generating a full stream, filtering a full stream, and then taking one, instead of moving like this, the process moves the other way around. The process starts with find first. I need one element of the stream. So find first looks at the filter step. Give me something. Filter step say, well, to give you something, I need a stream as input. Looks at names.stream and say, give me something. Name.stream generates the first string in names as the first element of that stream. This element is consumed by the filtering. Filtering applies the lambda. Now, if the lambda says that's not something you should keep, well, find first is still hungry. Okay? Find first still wants something. So filter has to ask one more element to the original stream. So another element comes to filter. If the predicate here says, oh, that one is a keeper, then filter is done. Filter outputs as part of its output stream one element. That element is consumed by find first, and we're done. So if 50,000 element passes your test, you are going to evaluate only the first one. If 49,999 elements pass your test but not the first one, then the first one is evaluated, rejected, and then you move on to the second one. The second one passes the test, goes to find first, and you're done. Okay? So this is yet another reason, and we'll cover that detail. We'll cover that in detail towards the end of the next module, if I remember correctly. But this is a kind of reason for which people love functional programming. And even some people say functional programming is actually declarative. To which I'm not quite sure yet if I fully agree to that, because back in the old days, a declarative language for me meant something completely different. But okay, still, a lot of very smart people agree that functional programming is declarative, so I'm okay with that. But the idea is that it's declarative. Why? Because you do not care about what happens. Okay? You do care about what happens because you have to understand what happens so that when you write code, you know what it's going to do, right? But what I mean by you don't care about what happens is that you don't really know how the iteration is going to go. For the sake of optimizing things, I could go, the old-fashioned way, generate a food stream, etc., or I could go the way that I just described. Okay? You leave some degree of freedom to the compiler to generate smart code. And it's going to be even more true when we start parallelizing stuff. Okay? So that's the whole idea. The whole idea is that you describe what you want. I want the first element that matches, that passes that predicate. That's really what you care about. And then if there are smart ways to do it, right, Java is going to find them. Question?
It's a silly question. I just want to know whether I can use a filter on a filter. As in, if I get a starting element with A and I want the last element to be N. So is it preferable to pass it through two filters, or can I use something like names.stream filter names.starts with dot filter name.name ends with something and then find first? Is that possible?
Yeah, but that would be applying two filters. So if I understand correctly what you are trying to do, let me send it back to you so you can correct me. You are trying to say, I want, for example, a name that starts with A and ends with Z. So I would say generate your stream, filter out whoever doesn't start by A, and then on the resulting list, filter out whoever doesn't end with Z, and then do your terminal operation like find first.
Okay, so I can probably create two functions. We have a starts with predicate. We can have another ends with predicate, and I can, after the dot filter, I can write a dot filter with ends. It won't give me an error saying that filter cannot be applied on filter.
No. So, okay, that's a good point. The question boils down to, so you are telling me that I can generate my stream, then apply one lambda by doing dot filter in the lambda, then I can again do dot filter after that and pass another lambda. Absolutely. That you can have as many intermediary operation as you need, okay? And I just realized, based on your question, that a lot of the example I used so far generate the stream, apply one intermediary operation, then a terminal operation. So that might have misled you to believe that, okay, that's all I can do with lambdas in Java 8, right? No, not at all. You can have like 50,000, intermediary operation here, all sort of filters combining with one another, and then you can have only one terminal operation. That's the only rule. So one at the beginning, one at the end, okay, source and terminal operation, but in the middle, as many as you need. Okay, so yes, you can combine filtering and have all sort of funny stuff there. So that's one thing about this slide. Okay, but again, this is stuff we already talked, so I'm just reiterating over it to get you comfortable. Okay, but the new thing on this slide is what's at the bottom in red, the found name dot or else. Okay, that's actually the new stuff, the cherry on the cake, so as to say. When you look at the way that we define the found name variable, we define it as final. So, okay, we tend to make a lot of things final, okay, lately. But really, we should have said final string. Because the first, the find first here is going to give us the first name that came through this pipeline. So the names inside of the parameter names are strings. Okay, names is a list of string. So we should get a string out of there. Here we are saying that what we are getting out of find first is an optional of string. So it's a new construct, a new Java 8 construct. So the idea of optional is it's like a wrapper. Okay, it's a wrapper that goes around an other data type. So in this case, instead of just getting a string reference, I'm getting this object that wraps around a string reference. And the only purpose is to make it more convenient to handle the potential that the string might be null. Okay? What happens when you filter things? Well, it happens that maybe you have a huge amount of names in that list, okay? But none of them starts with the letter you picked. So you said, filter name dot starts with, and then your starting letter is N, but nobody has a name starting by N. So what you get out of there is you go through your entire list, you generate the full stream, you filter out every element of the stream, and then find first terminates, and it says, well, I don't have anything else in my input stream, and nobody ever found anything, so my find first is nada. Okay? How do you say nada in Java? You say null. You say you ask me for an object, okay? And most of what we do with streams is based on reference data type, okay? I try to kind of work around so that we don't have to deal with int, long double, and stuff like that, okay? I stay with streams of objects. So what you get is pretty much the object I found is null. And if we do that, we could do that, okay? If we do that, then the part of the code from the previous slide that handle, that null special case needs to go back in there. So, question? Yeah, and then you.
Yeah. Sir, optional works like a list of string or a string?
It works like a string. So the question is, when you say optional of string, does it work like a list of string or does it work like a string? It works like a string. If you say optional of employee, it's just like a wrapper around an employee object, not a list of employee, right? Not a tree of employee or any collection. It's just one. Does that address your question?
Yeah.
Cool.
Two questions. First question, optional. Do we have a way of, so it's right now it's returning either null or the string, considering the filter finds it?
Yeah, that's the point.
Override the null, the point where I'm sending null and I want a specific one.
Okay, so that's exactly the point of optional, is to give us a way to handle the possibility of, well, maybe there is a string, okay? So I have an optional of strings, that means maybe I have a string object, maybe I don't. That's what it means, okay? So I'm going to go over the or else in this slide, and then next slide I'm going to show you another feature. You had a second question?
Yeah. So the filters, like you said, I can use multiple filters. So it's basically, if my first filter is not going to find a starting letter with, say, N, so it's going to send a null and it's not going to go to the next filter.
Yes, so you can use multiple filter. If your first filter pretty much ends up filtering out everything from the input stream it receives, then it's not going to generate anything in its output stream. The output stream will end. So the next filter step that is waiting to receive as its own input stream, the output stream resulting from the previous filter step, is going to get a stream that's ended, empty.
So in that case, if I have to write a kind of an OR, get me either the first get me the strings which either start with N or that end with M. So will I need an additional lambda which will take in those two lambdas and get me an output, or is there a way to work around it?
So the question is, if I want to, if I change my requirement and now I want any name that starts with A or ends with Z, for example, then the best way for you to do that is not to put filter after filter after filter. The best way for you to do that is to change the condition of your predicate. You can have a lambda here that is going to say pretty much, I don't know, let's call it, this name is great. This name is great is going to call starts with, let's say, A. And then if it starts with A, it's going to call ends with Z. And only if the two are true, then it's going to return true. So it's like a one-line lambda, that would use pretty much both starts with and ends with method. Okay? So you change your predicate, and inside the predicate, you can have a very complicated, condition. Yeah.
Yeah, can you tell the syntax, the whole syntax of the condition? How will it look like? Name tends to names dot start with starting letter. And
Okay.
What will come, and then names dot end with ending letter.
So the question is, can you give us an idea of how it's going to look, the code? Okay? So not on this Podium PC, but I can tell you what it's going to look like, where you have filter here, okay? Dot filter name a row. Instead of having a simple statement here, like one statement, you open curly braces. So you're going to provide several statements. And then inside of that, you could say, for example, return name dot starts with and whatever starting letter, okay, and then logical end, ampersand, ampersand, name dot ends with, I don't know, ending letter, and that's your Boolean expression. So you just return the truth value of a Boolean expression that combines testing that your name starts with a letter and logical AND operator ends with a letter. So there's nothing, I want to break kind of the myth there. There's nothing magical about this, right? A lambda is a function, it's code. So we always use lambdas, that say, I take name and I return name dot blah, blah, blah. Yeah, sure. Short lambdas are kind of the hallmark, of functional programming in Java 8. But you can have a complicated lambda. You can have full code here, like 10 lines of code. Whether it's a good idea or not from a design perspective, I don't know. I really do not have any opinion on that, okay? But it's just possible.
So you said like name arrow and then open the curly braces and then name dot starts with and my condition.
Yeah.
So do I need to write return before the condition? Or
Okay, hold on. Instead of me giving you like line per line, come to office hour, okay, and I'll show you the code like live on a keyboard. But you do need you have only one statement, so you do not need the return in this case. Okay, but if you needed a variable, if you had multiple line statement, etc., yes, you would need a return at the end. Okay, but we covered that already. The syntax of the lambda is either it's like something trivial like we have on this slide. Okay, in that case, that just means take the name, and the arrow kind of means return, and this is an expression which result I want to return. Okay, but then I can put curly braces. So like as you pointed out, if I put curly braces around just name that starts with, I think that was one of the first slides we covered, where we tried to simplify the syntax. If I put curly brace around one expression like that, I might as well remove them, okay? I don't need to add a return statement, it would work. But if I put curly brace, generally that means I want several lines, I want maybe temporary variables. So if you do things on several statements, then you need a return statement explicitly. Other languages are going to say, well, if you have multiple statements in the body of your lambda, I'm just going to assume that the last statement is an expression, and when I evaluate it, I'm going to return for you automatically the result. Okay? So again, that's the kind of stuff you pay attention to when you move from one language to the other. You know the concept, just be careful about the details, okay? Because they can spell errors. Yeah, other question?
So suppose I'm not using the find first method, instead I'm using the collect method and putting it into a list.
Okay.
All the names that are starting with a letter.
Okay.
So suppose I have 3 names that are starting with A, and then I'm using a list of string. Can I use the or else function on that, or else method on that list?
Can you use or else method on the list? No. So hold on, for the recording, your question is, what if instead of doing find first, my terminal operation is a collect, I take every name that starts with the letter specified, put them in, let's say, a list of string, okay? So at that point, you have a list of string. Yeah. So how do you handle, the potential of the list of string being empty? You just test for your list to be empty. But you will get, this is a very important point to understand, okay? It's subtle, but you will get out of your code a list of string, always. It may be an empty list of string, but it will be a list of string nonetheless. So you do understand the difference between an empty list of string, a reference to an object of type list of string, which tells you I don't have any string in me, and a null reference, which says I don't even have an object. What are you talking about? Okay. So what we are trying to avoid with optional is the second case. Optional is good when you are going to return to me either a reference to an object or a null reference. That's where optional shines. In your code, I know you will always return a list to me. So you will always return a reference to a list object. It just so happens that that list might be empty or not empty. Okay? Like you would return to me a reference to an employee object. Well, maybe that employee has a salary of $1 million or maybe 0. I don't care, but I still have a reference. So I'm not going to fall into the trap of doing a null pointer exception, right? A null pointer dereference, which will result in a null pointer exception. That's the key. So that's a good point. That's a good question here. So going back to our example here, like I said, we really want found name to be a string, but we choose to define it as an optional of string. So pretty much what's going on here is that because it's an optional, we get a bunch of methods for free on that new interface, optional of blah, blah, blah. And we can write the kind of code that you have in the last 3 lines here, where we are just doing in a fancy way, we are doing displaying on the screen, a name starting with, and then we display the starting letter, okay? And then this is the name that's the first name that started with that letter. So to display the first name starting with that letter, we address found name, and we just use a dot or else. And dot or else is just a way to say, if found name wraps around a string reference, and that string reference is null, then I want you to use this default value. That's it. So the expression found name dot or else parentheses, quote, and your default string that you want to use is going to always result in a string. So we don't have to make an if statement. We don't have to test whether, our string is there or not. We just say, I'm going to display found name, and I have a way to tell found name what I want its default value to be in case the string it wraps is null. We are good on that? Sounds good? So it's just, again, to make it easier. Okay, question?
Suppose I don't specify optional as string, so will it become a raw type or will it...
Oh, no. We don't do that. So the question is, what if I don't specify, string inside optional between the angular braces? No, you will specify string, because there is absolutely no sense here in saying, I want an optional of I don't know what. So yes, in a way, like you mentioned, it would be going back to raw object. So it's kind of saying, okay, I have a reference to an object of class object with an uppercase O, but I don't know if that reference will be null. Okay, so since the module on generics, we try to go away from, playing with reference on objects. So in that case, no, you're not going to find that the kind of people, the kind of programmer that want to use optional are the kind of programmer that want to go back to raw types, okay? There is maybe one use case, where you have to, I don't know, but yeah, we'll try our best to avoid it, okay? All right. So, or else is one of the method that you get, okay, with that optional. We're going to look at another one called if present. So the deal with or else is that it's perfect, if you want to just specify the default value, right? But sometimes you want to do operation with side effect, like sending some data over the network, displaying, on the screen, and you just don't want a default value here that is, for example, an empty string. You want to say, well, I'm glad that I could avoid writing an if statement with that or else construct of yours, but I still need my if statement, okay? So this is just a way to make it a little bit more palatable. So what you are saying is, I use found name, and only if found name is actually defined, only if found name is wrapping around a string reference that is not null, then I will trigger this code. And how do you specify the code you want to trigger? Lambda, okay? Just because, okay? We could do it differently, but it's just simple. We have a way to write, a few lines of code very, very easily in Java now. Let's use it. So that Lambda just takes a name, okay? And that name is going to come from the variable found name, okay? That's going to be the string that is referred to by found name. And you just display it, okay? So two construct like that to try to use optional, to work around things. I think one of your reading assignment has some interesting examples about optional on how to not do it wrong. So I'm not going to cover that in the slide, but really read your reading assignments, okay? That's why they're called reading assignments. But it's interesting because you have in the API of optional, you have everything you need to do ugly things, like, for example, let me test, if actually the string, for example, in found name, the string reference is null or not. And if it's not null, let me get that reference. If you find yourself doing that, it's no better than if you were testing for null, okay? So again, force yourself to do things differently in this class. Try to use actually this optional API the way it is intended to. Yeah, question?
Considering in the previous slide we used the terminal which I get starting with A in this case. So will the file name dot or else work in this case? Because
Okay.
I'm actually getting a collection.
No, you're not. So that's a good question. So we go back one slide. Names.stream. Let's say that inside of my names I have the three first names in that list start with N, let's say. Okay? So the first one gets filtered in. We keep it. So the output stream of the filter steps contains that name. That name is immediately consumed by find first. What does find first want? It wants one name. It just found one name. It's done. The terminal operation completed. The stream is shut down. The whole pipeline is shut down. So even if you have, your question was, if I have three names that match a predicate in my original stream, okay, what's going to happen here when I use or else? Again, that goes back to his question as well. The optional of string is one string. So your result is always one string or zero string.
Sorry, my question was if I don't use the ending find first, so
Oh.
I'm filtering out the names, and can I use the optional and in the return what?
Okay. So sorry about that. I misunderstood your question. So your question was, what about I don't, use find first? Okay. Well, then what terminal do you use? He suggested sooner, for example, what if I use collect and I siphon everything in my stream in a collection, okay, in a list, for example? Well, then your result type would not be an optional of string. Your result type would be a list of string, okay? Assuming you do a collect, collectors.to list. So the idea is find first is going to return one element of that stream. So if you have a stream of strings, sorry, this is really difficult for me, then what you are going to get is an optional of string, okay? An optional of that element. It's there or there's nothing. But if you say I collect into a map, I collect into a set, I collect into a list, a tree, whatever you want, then what you are getting is that collection. So you cannot do or else. Again, the reason is that you don't have a wrapper around like one reference that may or may not be there. What you have now is a collection, and you can test if your collection is empty, but the collection object exists. Okay? All right. So we have this construct if present, which is just a glorified if statement, and these are the two that we are going to use, in the context of this course. But again, if you take a look at the reading assignment, you are going to see that there are a lot more stuff in the API of optional, including some stuff that would allow you to pretty much, lose any benefit about using optional. So make sure you read that, understand it. If you have any question, as usual, use the forums, okay? Or come to office hour or whatever is most practical for you. All right, so now we're going to dig into, I would say, the even more fun aspect of Lambda, reducing. So we talked about terminal operation, and most of the examples that we took so far, I think we took the sum example, we took the find first example, so maybe it's not most, but at least two of those examples, you notice maybe that they are taking an entire stream and they are collapsing it into a value, a single value. I don't want the names that start with N. I want to know how many names starts with N. So I would use .count, terminal operation. So this is a more generic technique. The more generic technique that is behind all of those particular cases, like find first, count, is called reduction. Okay, you have a stream, you want to reduce it to a single value. So this is going to be a pattern that you're going to see like everywhere, a lot of times, okay? Including but not limited to probably the exam. So pay attention, okay? If you were dozing off, like it's time to wake up. So we still have our friends here, our friend list, okay? We want to display the total, what do we want? The total number of characters in all the names. So that example is going to do two things for us. It's going to give us an example of reduction that we haven't seen before, and it's going to also start opening the Pandora box on, but I don't want a stream of objects. I just want a stream of int. To which the response is, I don't care. You're using Java. I use objects, okay? But that's just me anyway. So friends.stream, we generate our stream based on that collection. Then we use a map operation, intermediary map operation. It just so happened to be a map that's going to allow us to go from a stream of object to something that is not a stream of object. It's a stream of primitive data types, and more specifically, a stream of int primitive data types. So think about optimization. Somebody decided that this was the part of the code that was super critical, where we were spending 90% of our execution time. It had to be optimized. We are going to save memory or speed or both just by mapping to int. That's the context, okay? So it works like a map. The only difference is that I take whatever type is in my stream, so strings, and I return something that is an int. So now I have a stream of int values. Okay. So the fact that we have those specialized streams, okay, stream of int, stream of long, stream of double, allows us to have, also specialized terminal operation. For example, it doesn't make sense to do, I'm going to do dot sum on a stream of employee. You would have to define it, what it means to make the sum of two employees. Are you talking with the sum of their age, the sum of their salary, I don't know. So we cannot have that kind of operation, but those operations are handy to be available for those numerical data types, right? So that's one of the reasons also you might want one day to use that map to int or map to double or map to long, okay? So in this case, one intermediary operation, but like I said before, we could have many. And then dot sum, we collapse the entire stream into one value, one int value. So visually, this is what's going to happen. Here's the example of our stream based on what I put in my collection a few slides ago. First, I'm mapping to int, and in this case, I cannot be lazy. I have to map every element in the stream. Why can't I be lazy? Because the terminal operation is very, very hungry. Okay, so if I ask you as an exam, why can't we be lazy in this code? Do not say because, the step is hungry, okay? Do what I say, don't do what I do, all right? So this is just a metaphor. But what it means is that it's going to consume everything until the stream is done, until the stream closes, okay? So that means that sum is going to say, give me more, give me more, give me more. Once I reach here the end of my stream for the input of map to int, I generated all the ints I could from that stream. That's the end of my result stream. Now the sum terminal operation knows that it's done. So what does it do? It just adds, as you would guess, it just adds all the value in the stream of int, and we get a result that is, for example, in this case, 26, I think. Yeah, except if I messed it up. But so that's exactly how you would think of a reduction in those simple examples. But the beauty of it is that we are going to be able to write code based on that framework. Take a stream, map an operation to each element, maybe filter out element, maybe do over intermediary operation, and at the end reduce into one. Okay? Yes, you had a question.
Yeah, I had a few doubts. Sum is a method provided by the stream class or provided by the integer class, or
okay, so the question is, where does sum come from? Does it come from the integer class? Does it come from the string class? It comes from the stream of int class. Okay, so you can have a stream of different things. Okay, there are specialized streams. Actually, it's not a stream of int, sorry, it's an int stream, uppercase I, uppercase S. Okay, so that class provides you those methods, those terminal operation for streams. Okay, good question. Yeah.
Like map.int. So how will it be giving the data to sum? Will it be giving, okay, for I'll give you 5, then I'll give you 4, then I'll give you again 4, and then sum is okay wanting, like, will it be giving the whole 5, 4, 4, 4, 4, 5 whole stream at a time to the sum? Or will it be giving 5 once, then 4, and then it is adding and keeping it, then it is giving again 4, then it is adding and keeping it?
So the question is, how does the stream goes from map to int to sum? Is map to int generating the entire string of number 5, 4, 4, 4, 4, 5, etc., and then sum start executing, or does it give the 5, sum does something on it, etc.? I don't know. I don't care. That's the key. That's the key of being able to say functional programming is declarative, right? As a programmer, what I know is what I want. I want you to apply this transformation to every element of that stream, okay? And conceptually, I want you to sum those. But if there is a smart way for you to do it, you meaning the Java compiler, okay? As a programmer, I don't care. If you find a way that consumes, one element at a time, I'm okay with it. If you wait for the entire stream to be done before to start doing the sum, I'm okay with it. If you can parallelize the mapping and then you have to synchronize, wait for all the mappings to be done and then generate the result, I'm okay with that. It's even faster, right? I have like 32 cores on my Spark machine. Why don't you use them? So that's the deal, okay? That's implementation level. The only thing that matters at implementation level is what the language, the Java 8 language specification tells you should happen, okay? So for high-level programmer, we seldom look in the Java language specification, okay? Only when we want to detangle some things that we are not sure we understand. So these are not necessarily the easiest to read, documents. But for people that implement Java virtual machine or compilers or stuff like that, or even IDE that are supposed to parse your code, these people are very interested in what Oracle has to say about what should happen under the hood, okay? So if you are ever in a situation where that matters, okay, so you're no longer at the application level, application programmer level, you are maybe at the system level programmer, then you go to the specification and you check that your JVM does it that particular way. Because all JVMs are going to be compatible with the specification. But any of you that had experience, with compliance to specification, you know that specifications are written in plain English. They are not unambiguous. Code is unambiguous. Okay? Mathematics are unambiguous. But a specification written in English always have loopholes, things that are open to interpretation. For example, if in my specification of my own personal Java version, I say, well, this is what I want to happen, but I do not provide enough detail to answer your question, then two of you try to implement this. One of you is going to generate the full stream because sum is not lazy. So generate the full stream, then process it. Another one of you is going to say, well, this is how I do it with lazy terminal operation or potentially lazy terminal operation. So I'm going to use the same principle. If the Java specification doesn't tell you which one you need to do every time, then it's up to whoever implements the compiler and the JVM. Okay? So that can change from moving, to Oracle JVM to OpenSDK to Dalvik, for example. Yeah, you had a question?
Apart from right now, I have a list of friends. If I have a list of integers, say, which already tells me the number, the character count, and can I do the friends character count dot string dot sum directly without mapping? What do I need?
Oh, okay. So the question is, can I do friends.stream.sum? Right now, with the way we define our variable, no, because friends, is a list of strings. So your stream is going to be a stream of strings. But
if I have, instead of the list of strings,
you have a list of int?
I have a list of integers and I just want a sum rather than, can I do a friends dot integers on the sum without mapping it?
If you generate, and I don't care how you generate it, okay? But if you generate somehow an int stream instead of a stream of, let's say employee or strings, then yes, because you have an int stream, you can call the terminal operation sum on it. So without any map to int, without any filtering, if your original stream is an int stream, then you can apply sum to it, no problem. All right. So we have time to, I would say, at least finish this. So let's take a look. So what we want to do here is we want to look at the more general concept of reductions. Okay. So we want to write our own reduction. It's nice to have count. It's nice to have sum. It's nice to have all of those things. Okay. But sometimes we want to develop our own reduce operation. Okay. So what we want to do here is we want to say, let's start with friends again, always. Friends.stream. So now I have a stream of strings, and I'm going to call this reduce operation. That's what we introduce. Okay. It takes a lambda as parameter. That lambda, I can tell you that much, is going to take two parameters, two names in your stream. Okay. So two strings. It's going to do something here. all right? And it's going to return to us something that is an optional of string. So the idea of reduce is you give me 2 elements from your stream, okay? And I was going to say 2 consecutive elements of your stream, and yes, that's me, the old, programmer talking, because they really do not have even to be sequential, okay? Especially if you're using parallel streams. But the idea is, let's stick to sequential stream for now. Give me the first and the second element of your stream, and I will return a result that is also an element of the same type, that's what I found in your stream. So you give me 2 names, I return a name. Then you give me 2 more names, I return a name. And there's a trick there, okay, that defines what reduce means. But I'm going to come to that in a second. And then at the end, well, I can use, a long name if present, or a long name or else. Nothing new there, okay? We are just using leveraging the benefits of having an optional instead of a string. So the key is, what do we do in that box here? And what is that little trick that I told you about, that makes it possible to chain those calls to reduce, all throughout my stream? Well, again, let's start visually. Let's visualize what we want reduce to do with those 2 parameters, and then we'll just show how it's implemented. So we have our original stream of names, okay, stream of strings. So originally, I'd like to take the first 2 elements. And my purpose in this example is to find the longest name. So Brian is what, like 5 letters, Nate is 4 letters. So I want my first reduce to tell me I'm keeping the name Brian because it's the longest, okay? And then the idea of those intermediary operation is that you slide them over the stream, right? When you do a map, you apply it to every element of the stream. So I want to apply my reduce alongside the stream. But here's a little trick I was talking about. The next time you call reduce, or you don't call reduce, the next time reduce is called on your behalf, okay, it's going to take as first parameter the result of the previous reduce, and as second parameter the next element in the stream. And you apply the same step, right? The step is, let me see how many letters in Brian. Let me see how many letters in Neil. Well, Neil is smaller, so I keep Brian, okay? So at this point, the first step was kind of a weird, special case. I need 2 elements from the stream. But from now on, every time, my first parameter is the result of the previous application of the reduction. My next parameter is the next element in the stream. And I keep moving like this until I get to the end of my stream. And now I have kept Brian, because that was the longest, let me double check, yes. That was the longest name in that list. Scott has 5 letters too, but let's assume we do like greater than, instead of greater equal. So we want the first one that's actually the longest in the string. So we go back to this. Any suggestion on how we would write this?
There has to be 2 for loop to go through each element.
Okay, so first reflex, there has to be 2 for loops to go through each element. No, that's exactly what we want to avoid, okay? Forget about for loops. What we want here is we want to get that job done just by providing this part here in the gray box of the lambda expression. Any other suggestion? Yeah?
Name one dot length greater. You probably have a condition where you can check the lengths.
Yeah?
You can say if name one dot length is greater than name 2, then return name 1. Else return name 2.
So I'm not going to repeat that because it's going to come on the slide, but yes, that's the correct answer. And we can compress that. Instead of using an if statement, we can use a ternary conditional operator, okay? So that's the syntax that is here highlighted in red. And that allows us to have one expression that in practice, what it does is it tests this condition. So if the length of name 1, and this is a greater than equal that causes poor Scott to not be actually welcomed in the VIP club. So greater than equal name 2 dot length. If I found something that is positively bigger, longer as name, then I take that one. Otherwise, I take the other one. So that's the return value of that expression, M1, M2, for those of you that are not familiar. Yeah?
So if I wouldn't have written that greater than equal to, just written the greater than, in that case, where will the loop go? Because Brian and Scott both have the same length. So it's a false. So it return the name to, right, in that case.
Okay, so your question is, who would be returned if I have greater than? Okay, if I have greater than, the only comparison that matters is the last one, right? So Brian is five letters, so name 1 is Brian, name 2 is Scott. They're both 5 letters. So is name 1 greater equal to name 2 dot length, then I return.
If I don't write the equal to, if I just write name 1 is dot length is greater than name 2 dot
Oh, so then it's false, so I return name 2. Yeah. Greater equal is going to allow Brian to stay in. Greater than strict is going to allow Scott to be selected. That's the only difference. Yeah, question?
Where did you specify name 1 will go to the first index and name 2 will go to the second index? Like,
Okay, so the question is, where did we say that name 1 would be the first element, name 2 would be the second element, and then name 1 would be the result of the previous reduce? I'm extending your question, and name 2 is the next element. It's magic. That's just how reduce is implemented, okay?
and where's the terminal? Like, we require a terminal like find first.
The terminal, okay, so the question now is, well, where is my terminal? The terminal is reduce. The terminal operation is reduce. What I mean, by the way, jokes apart, by its magic, what I mean is that this is exactly how reduce is coded. Okay, so when you say, where did they decide, to take the first 2 elements and then apply, the result as first parameter and then the next element as second parameter, etc. That's the very implementation of reduce. So it's not something that should happen, like because it happens. No, it happens because this is how reduce is actually implemented. That's what it's meant to do, that's what it's supposed to do, and that's what we are going to rely on when we use reduce, okay? It's like asking, when I use an if statement, or more closer to this example, when I use a for each method on a collection, where does it decide to take the first element and then go to the next and then go in the code of for each? Where do we decide, how reduce behaves? I just showed you how reduce behaves. Where we decided that is in the implementation of reduce. Okay. Now, second part of your question, dot reduce is a terminal operation. Okay. A sum is a terminal. A count is a terminal. A reduce is also a terminal. Sum and count are examples of reduce operations that are already pre-packaged for you, written for you. Reduce is one reduce operation where you can specify the lambda yourself. So you can do things that that you want to do that are not already available in the library, for example. So let's see. And this kind of goes back to your question. Part of your question was, well, what about this first step where I need 2 elements in my stream, right? Well, this is kind of addressing that need. You have a version of reduce that takes only the lambda as parameter. That's what we saw on the previous slide, okay? But you have also a version of reduce that takes 2 parameters. The first one in red here is actually the default value. So the funny thing with this is that when you apply actually this version, it's like if the first call to reduce takes as first parameter Steve, the string Steve, and as second parameter the first element of your stream. So it's kind of more natural, okay? It's kind of subjective, I'll give you that, but to me it feels a little bit more natural, because what you are saying is, okay, I bootstrap my process with Steve as a result. Now look at the first element. Now look at the result of this and the second element. Result of this, third element, and so on and so forth, okay? So there's not that idea of, well, to start off with, I need 2 elements. Well, I'm going to give you 1 default element so that you don't need to take 2 elements from the stream the first time around, okay? But again, this is more like implementation detail than anything else. A quick remark about the return value of that thing. You will notice that Steve or longer, the variable that we define here to hold our result, is no longer an optional string. It's a string. Yeah. Well, yeah, it makes sense, right? Because now, just like when we use or else, the whole point of or else was Now that I have an optional and I can use or else, I can give you a default value. I know I'll always get an object from you. No null reference, okay? Here, the idea is kind of the same. When I call reduce with Steve, I know that I'm going to get, at the very least, even if the stream is completely empty, I have Steve, okay? So I'm going to get something that is non-null. You had a question? Yeah.
Instead of giving it as a Steve as a separate parameter, why not replace N1 by Steve and just
Ah. Okay. So your question is, why do you pass Steve as parameter of the 2-parameter version of reduce? Why don't you put Steve directly instead of N1? Because if you do that, it's not the same code. Okay? And I'm not just meaning that the difference is that you move Steve here. I mean the code behaves differently, implement a different logic, right? The logic that you implement is you are trying to reduce. I mean, you could not do that first, but even if we could do that, you are trying to reduce your stream by comparing every element to Steve, and only Steve. Whereas in this version, what you do is you start with Steve as the first element. Maybe you keep Steve. Maybe you keep the first element. If you keep the first element, Steve is gone for the rest of your intermediary operation, right? Whereas with your version, if you shove Steve where N1 should be, then you are stuck, comparing everybody to Steve, and that's it, okay?
basically providing a default value to the function? In case nothing works out, I get that default value.
Well, I guess you could say that you are providing a default value too. The only thing I'm concerned about is if we look at it like that, then we are saying that we provide a default value in both cases. So we just have to be careful that yes, if we can call that providing a default value in both cases, it's true, but those two differ in how they behave. So just keep that in mind, okay?
Because in this case, if my
No, it's okay.
if I want to return a null, if my first parameter is null, instead of Steve I use null. Is there a way that I can overuse the optional function anywhere, considering I don't get a longer function and I do want to still use the option?
Well, I don't know if there is a way to repeat your question for the recording. I don't know if there is a way to actually get back to the point where we have an optional as a result, because if you provide Steve, then yes, you're not going to need an optional. Now, if instead of Steve you provide, a null reference, I don't know. Honestly, I don't know. What you are saying is indeed, my default value is a null reference. So if you do not allow me to return an optional, then I'm going to have to test for the null reference by myself. I don't have a response for that. I would have to try it. Okay, it's a good example but I don't know. I'm hoping that somehow it's going to prevent us from passing null, because that kind of destroy, the whole idea. I'd like to have the flexibility to do it as a programmer, but then I'm back to to manipulating everything just like without optional. It's kind of dirty. But anyway, okay, we're going to stop here. Next time we're going to talk about joining elements. Okay, so we're going to keep going into those reduction step and do more and more complicated stuff. We should be able to wrap up the remaining slide of that slide deck next session and probably start on the next one. So I'll post them online before the next session. All right.